Let's look at an LC circuit. An LC just is a fancy name for inductive and capacitance. L is our abbreviation for inductance and C is our abbreviation for capacitance. So what we have here is a capacitor and an inductor in parallel with no resistors. And what we do to get this thing started is briefly supply a pulse of voltage. Okay, and if you notice there, for a split second we had a flame showing up at the switch and we had a flame showing at the battery. This is because we had a large capacitance that we were charging, and the capacitor charged instantaneously. The inductor has this property of being a little bit more sluggish, so most of the current went in to provide a charge on the capacitor, an initial charge. And now if you look at the circuit, you notice this back and forth motion of electrons as the capacitor discharges through the inductor, and the inductor, being reluctant to change the value of current, lets the current continue even after the voltage on the capacitor reaches zero. The inductor forces the current to continue flowing in the same direction it was flowing before. So the ultimate effect is you get this back and forth motion, this sort of like sloshing back and forth of electrons. And this is typical of an LC circuit. And this is what we base devices called oscillators on. Oscillators are devices that take energy and transfer it from one form to another. On the capacitor, it's potential energy, and in the inductor, it takes the form of sort of kinetic energy. And so we know from earlier things we've learned in science that we have two main types of energy, potential and kinetic. And these two components are exploiting this fact, and one of them is allowing the voltage to exist in the form of potential energy, and the other one is storing energy in the form of kinetic energy, the inductor. So what does this remind you of while this current is flowing back and forth? And if you remember from your science classes, it reminds you probably of a pendulum. So let's look at a pendulum alongside this and see if we can get these two things working side by side and showing how very similar they are. A pendulum, if you remember, takes potential energy in the form of the height of a mass and converts it into kinetic energy while the mass is falling, and the mass actually moves past the lowest height it can be at, moves past that, and because the mass has inertia, it moves on back up. And so a pendulum is constantly converting potential energy into kinetic energy and back again. And because of that, it has this back and forth motion. And the LC circuit is basically doing a very similar thing, just using electrons in charge and magnetic fields instead of masses and height. Another system that this is very similar to is a spring mass system. A spring mass system is a system that allows the weight of a mass to be converted into kinetic energy as it moves, and eventually that kinetic energy, when the mass stops moving, is converted into potential energy on the spring in the form of tension. And so the spring goes back and forth between tension and compression, and in the process the mass moves up and down, and it's converting this energy into kinetic energy, the energy of motion. So the mass moves up and down while it's exchanging energy with the spring, and putting the spring in both compression in one situation and tension in the other. So anyway, hopefully this will kind of open your eyes a little bit to the possibilities of LC circuits and explain a little bit more about what LC circuits do.